Well, this video is for Math 70, and this is about solving linear equations. So linear, and we'll talk about this a little bit later in the term. Linear is talking about an equation that when you graph it is going to give you a straight line. And these, typically have an equation y equals mx plus b. The key here is that this is x to the first power, okay? So that means we're going to be when I say linear equations, that means we're going to be solving equations that have x to the first power in them. If you get into Math 95 and Math 111, you'll see equations that have x squared and x cubed and so on. Those are not linear equations. So this is all about how to solve linear equations. And the idea here is that we've got an equation in balance on either side of the equal sign, right? And the idea is that we might start out with something like, 3x plus 7 equals 5x minus 9. And the goal is by trading back and forth between these sides, right? If you add 9 to both sides, then we'll have 5x here and 3x plus 16 over here. Then we'll take away 3x on both sides. And the whole idea here is this is like a balance, right? And so when you do something to both sides, you're keeping this in balance, okay? Which means that it stays equal. And so here we get x equal to 8. So the goal usually is to get all your x's on one side, get everything else on the other side, and then isolate the variable so that we get a solution. And this process is pretty ancient. The Chinese, I think, had a slightly different method. I'm not sure what their algebraic methods were. They often used a guess and check process. This process of trading back and forth between the sides comes out of India and the Middle East. In fact, the word algebra is an Arabic word, aljabar, which is all about this trading back and forth between the sides of an equation. And so this is a really useful process, which I think can be very helpful in solving equations. All right, so let's run through some of these here. We'll start off with problem 2. We've got 3 times 30 plus s equals 4 times s plus 19. All right, so we need to distribute and get things simplified and then move to get all the variables on one side and everything else on the other side. So this is going to be 90 plus 3s equals 4s plus, 40 and 36, so that should be 76. And then I'll subtract 3s on both sides, and that'll give me 1s plus 76 equals 90. And then subtract the 76 on both sides. And what are we going to get here? 14. Okay, so there we go. S equals 14. Okay. Let's see here. Problem 4. We've got 3 times 2 plus v minus 4v equals v plus 16. Okay. So every equation, right, has two sides. And whenever you do something on one side, you've got to do the same thing on the other side to keep everything in balance. All right, let's see here. So again, to start out here, I'm going to distribute the 3 there. Over on this side, there's nothing we need to do. All right, let's just get this side simplified, and then we can collect our variables afterwards. All right, so let's see. This will be 6 plus 3v. And I don't multiply the 3 times the 4v because it wasn't inside the parentheses, right? This only gets distributed to what's inside the parentheses. Now, if these are on the same side, I don't do the opposite, right? I see a lot of people, not a lot, but I sometimes see people do this. you're doubling. You're doing the same thing twice on the same side, and you're doing nothing on the opposite side. That's going to throw everything way out of balance if you do something like this. Okay? If you wanted to add 4v here and here, there's nothing wrong with that. In fact, I'll go ahead and do that. Plus 4v, and then if I do it on the other side of the equals sign, everything stays in balance. Not a problem. This cancels out. 6 plus 3v equals 5v plus 16, right? Don't forget you've got a 1v plus 4v makes 5v here. Okay, now I'll collect all my variables here and then move that 16 over to this side. So subtract 3v on both sides, and that leaves me with 2v plus 16. And now subtract the 16 on both sides. 2v is negative 10. And then divide by 2 on both sides. So v is negative 5. Okay. Let's see what else we've got here. Let's see here. Yeah, let's do number 6. 4 times 3y minus 1 plus 14 equals 5y plus 2. All right, so again, we want to distribute here first 12y minus 4 plus 14 equals 5y plus 2. Okay, well what I was going to say on this problem right here, if I didn't add this 4v over, I could have done 3v minus 4v, right? And that's what I'm going to do here. I'm going to do negative 4 plus 14. That should give me positive 10. And then I'll move the 5y over here. So 7y plus 10 equals 2. Subtract the 10 on both sides. 7y is negative 8. Divide on both sides by 7. These cancel out. Y is negative 8 over 7. If you want to turn this into a decimal, that's fine. The sevenths are not really good for a decimal. 7. It's a repeating decimal that looks like that. I like to keep things in a fraction if I'm dealing with sevenths, because their decimal representation is not really simple. Okay. So I'll talk more about that when we run into more answers that are not whole numbers. And don't get worried if you don't get an answer that's a whole number. Don't worry about it. Okay. It doesn't mean that it's wrong. You can always check your answer out by plugging it in. Okay. Let's see here. Okay. Let's look at, what do we want to look at here? Let's look at problem 10. Got 9 plus 3 times y minus 12 equals y minus 7. Well, this is very similar, actually, in setup to this problem over here. We just need to distribute this 3 into the parentheses. Now, a mistake that people sometimes fall for is they see this 9 plus 3 and they're like, oh, I'm going to do that easy part first. That's 12. Can't do that. Can't do that, right, because of the order of operations. This multiplication has to happen before you can do any adding or subtracting, okay? So, the 9 is going to stay the way that it is, and then when we distribute the 3, we'll get 3y minus 36. Okay. Now we can combine the 9 and the negative 36, right? 9 minus 36 should be negative 27. And then let's see, I'll add the 27 to both sides. Now notice how if you're on the same side, you don't do the opposite, right? It's when you're changing sides that you have to do the opposite sign there. Okay? Let's see. Okay, so this is going to be equals y plus 20. subtract this 1y on both sides. And over here, 3y minus 1y is 2y. And then divide by 2 on both sides. So y is equal to 10. Okay. Let's see here. Oh, I was just thinking about checking this on the calculator. If you've got a calculator, it can be helpful to check your answer. Okay. So let's go ahead and do that here. This one's, it's going to be kind of difficult because of the form of the answer here, negative 8/7 plus 14, 5 times negative 8/7 plus 2. Okay, so, and the key here is that both sides be equal to the same thing. So let's take the calculator, 5 times negative 8/7 plus 2. So this, the calculator is telling me negative 3, and then here's this decimal that comes out of the sevenths. All right. Over here, 3 times negative 8/7 minus 1. Oops. There we go. This will be negative 4.42857, like that, and then plus 14. So now we'll multiply this by 4. And then add 14. And there we go, negative 3.7142857. And that's exactly the same thing that we've got here. So that's kind of a pain. It's a little bit of work. But what I was saying a minute ago is that don't get scared if you don't get a whole number. It doesn't mean your answer is wrong. And if you're ever not sure, plug it back in. Check and see whether or not both sides end up being the same. This one, it did check out, okay? I don't ask you to do that for every problem, but I do ask that you understand that it's something that you can always do for yourself to check your work, okay? All right, let's see here. Let's look at problem 12. Okay, 18x plus 3 times 4x minus 9, and then over here negative 6x plus 69. All right, so this will be, right, this 18x stays the way that it is, and this 3 gets distributed. That'll give us 12x minus 27, and then negative 6x plus 69. All right, so these are on the same side, so they just get added together. This will be 30x. Everything else stays the same. Now what? Now you get to choose what you want to do. I'm going to bring this over here, and I'm going to bring that negative 6x over to be with the 30x, right? Like that. So this will be 36x minus 27 equals 69. And then I'll add the 27 to both sides. And then what's that going to be? It looks like 96. And so then we just have to divide on both sides by 36. And let's see here. I could reduce that if I were in the mood to do so, but I think I'll just put it in the calculator. And so the calculator returns an answer of 2.6 repeating. So that's 2 2/3, or what is that? 6, 7, 8/3. 8/3, 2.6 repeating, or 2 2/3. Those are all good answers for this problem. Remember, don't just say 2.6. That's a different number. Okay? All right. Let's see what else we've got here. Oh, 14 is kind of interesting. We've got some decimals here. 0.5 times 6x minus 8, and then 1.4 times x minus 5 minus 0.2. There are some things that you can do in this problem. A lot of textbooks talk about clearing out the decimals. You can do that if you want to, but these decimals aren't so bad to work with. This is a half times 6x. That'll give us 3x. 1/2 times minus 8 is minus 4. Here, 1.4x. 1.4 times 5, you've got a calculator, and you don't necessarily have to do it on a calculator, but if you want to, you can. It'll come out to be 7. And then we'll leave this minus 0.2 there. Now, the minus 7 and the minus 0.2 are going to combine to give you negative 7.2. Okay? All right, so now we're in a similar situation that we were right here, right? So I'm going to collect all my variables on one side, collect everything else on the other side. So let's subtract 1.4x. 3 minus 1.4 should be 1.6x. And then add 4 to both sides. Let's see here, 1.6x. This looks like it's going to be negative 3.2. Divide on both sides by 1.6, and x equals negative 2. All right. Let's see, what else? Number 16, we've got some fractions here. 3/5 x minus 2 equals x plus 1/3. Okay. So, there's not a whole lot to do in this problem except that you're working with fractions. You've got a calculator. I encourage you to use it. Okay? I don't necessarily, I can't remember if I explained this before or not. I've talked about this in other videos for other classes. I don't know if I've said this for your class yet or not. I frequently don't use the calculator when I'm at the board just to save time, okay? Because it takes a bunch of time for me to come over, grab the calculator, type everything in. If I can do it in my head, I do. But I encourage you to use the calculator, have it handy, and what I really encourage is for you to try to do it without the calculator and then check yourself and see how you've done. I think that's the best way to kind of sharpen your arithmetic and computation skills. Okay? All right, so let's see what we've got going here. I'm going to do the same thing over here that I just did over here, where I collected the variables on one side and I collected the numbers on the other side. I think in this case, I'll collect the variables over here, right? This starts with 1x. I'm going to subtract 3/5 x from it. That'll leave us negative 2 here. 1 minus 3/5, that's 5/5 minus 3/5 is 2/5. Okay, there we go, step 1. Next, move this over to this side. Let's see, this is 6/3, negative 6/3 minus 1 more third. That's going to be negative 7/3. And you can turn these into decimals if you want to. What I recommend for these repeating decimals, what I do on my calculator, is just hit the repeating 3 a bunch of different times. Right? If you want to turn that 1/3 into a repeating 3 in a calculator that can't handle, most of these calculators can't handle repeating decimals, just put in, I don't know, 8 or 10 3s. And then whenever your answer comes out, you're going to have to round it again. Maybe I'll take the calculator and talk about this in a minute. Okay, so again here, if you're doing this on a calculator, you might want to divide on both sides by 2/5. Okay, and let's see, what would that be? Negative 35 over 6, it looks like. Okay, I'm in the habit of multiplying by the reciprocal, right? I take this and multiply by 5 over 2 and do the same thing over here. So now the 5s and the 2s all cancel out. And then there's our negative 35 over 6. Okay, let's look at this on the calculator here. So for one thing, let's see, let's get this focused. There we go. So for one thing, I'm going to take that 2/5, turn that into a decimal, 0.4. Take the 1/3, turn that into a decimal. There's that repeating 3. So then what did we do? We did -2 minus, and then just hit the 3 a bunch of times. And there it is, -2.3 repeating. And then we want to divide this by 0.4. And so there's our answer, -5.83 repeating. And you can see, I'll go ahead and put the fraction version in there. It's the same thing. Okay. So there's what it looks like on the calculator. And I always say, you know, any of these answers is fine. -5.8 with a line over the 3. Okay, that's fine too. Not a problem. All right. Let's look at a couple more problems here before we wrap things up. Okay, let's see here, number 18. All right, 1/5 times W plus 2 equals W plus 4. So this would be 1/5 W plus 2/5 equals W plus 4. All right, well, this is similar to what we saw over here, right? Because this started out as just x in that problem, but I think it's really helpful to understand that there's a 1 there. So when I go to subtract the 1/5 W, so this is 5/5 minus 1/5, that'll leave us with 4/5 W plus 4. Now let's subtract the 4 over to the other side. So 4/5 W equals, let's see here, 2/5 minus 4. There's a variety of ways you can do this. We should come out with -3 and 3/5. If you turn the 4 into fifths, then you'll have 2/5 minus 20/5, and that's -18/5, which is the same as -3 and 3/5. All right. All right. Let's make some space here. And the same thing goes for this problem. If you want to turn these all into decimals, just do a good job of it. That's all I ask. Okay? I'm not going to force you to do this one way or another, but I ask that whatever you choose to do, do it well. All right? Let's see. Now we've got -18/5 equals 4/5 W. I'm going to do this thing where I multiply by the reciprocal. So the 5s and the 4s cancel there. And what do we get here? The 5s cancel. 2 into 4 goes twice. 2 into 18 goes 9 times. -9/2, or 4.5. Okay? So that's a relatively straightforward problem, but numerically it's a little bit tricky. Okay? But again, you've got a calculator, and I want you to be comfortable with it, and so I think it's helpful to practice doing this with and without a calculator, or if you don't have time to do it both ways, choose the way that you prefer and practice doing it that way. All right, got 2 more problems to look at. Let's go ahead and finish those up. Problem 20. Got 3 times x minus 4 equals 2 times x minus 8 plus 7x. All right, so we have to distribute here and here. So 3x minus 12 equals 2x minus 16 plus 7x. So again, if we want to trade sides in this equation, right, if you want to move something from one side to the other, you do the opposite, all right? But here, the 2x and the 7x are on the same side. This is a positive 2x, this is a positive 7x. That makes positive 9x. Okay. All right, let's subtract 3x on both sides. Don't lose this negative sign because that's a negative 12. 6x minus 16. Add the 16 over here. Those cancel out. 6x equals 4. Divide on both sides by 6. And the x is equal to 2/3, right? 4 over 6 is 2/3. If you did this on a calculator, you'd get a repeating 6. That's fine too, so long as you put a bar over the 6. Okay? Now, something that happens here, sometimes when people see, well, let me make up a new example here. This is the classic example. It's like people get an answer that says something like 3x equals 1. Let's see, let's make up something else. Let's say, let's do this one. 6x equals 3. Yeah, I see this a lot. Sometimes people choose, they're like, oh, I got to divide on both sides by 3 here. No, no, no. You have to divide on both sides by what's happening to the x. What's happening to the x is it's getting multiplied by 6. That's what you need to divide on both sides by. Okay? So what I'm saying is don't be afraid if you've got to divide a smaller number by a bigger number. All that means is that your answer is smaller than 1. Okay? Don't get scared off and go down the wrong path just because you have to divide a smaller number by a bigger number. It's sort of the same idea as don't think your answer is wrong just because it's a fraction. Okay? All right. Let's look at one more problem here. 22. All right. So, negative 2, negative 3x plus 7, plus 6, and 4 times x minus 2. Okay, so distribute positive 6x minus 14. That 6 stays the way that it is, and then we'll distribute the 4 and get 4x minus 8. So let's put these together. They're on the same side, so we just calculate. Minus 14 plus 6 makes minus 8. Okay, now I'll move the 4x over to this side. Those cancel out. That leaves me with negative 8 here and 2x minus 8 on this side. Add the 8 to both sides. Leaves you with 2x here. On this side, you get 0. Okay? So normally, when I cancel this out, I don't write 6x plus 0, right? Because I don't need to put a 0 in there. But over here, if there's nothing left, we need a 0, okay? Because we need to have a number there. Because we haven't finished the problem quite yet, divide on both sides by 2. 0 divided by 2 is 0. Okay? Sometimes people get confused about doing 0 divided by something versus doing something divided by 0. This is not defined. Dividing by 0 is not defined in our number system for a variety of reasons. I won't get into it in this video. If you're interested, I'd be happy to talk to you about it. But this is not defined in our number system. We can't calculate that value. This is equal to 0. Okay? And this is the answer, x equals 0. And we can check this out. Let's go ahead. This is the last one, so I'll go ahead and check my answer by plugging 0 back in. Negative 2 times negative 3 times 0 plus 7. And then on the other side, 0 minus 2, right? So this is not saying that there's no answer. This is saying there is an answer. The answer is 0, okay? So over here, This is 4 times negative 2, which is negative 8. All right, what's happening over here? Negative 2. This is 0. So times 7, negative 14 plus 6, negative 8 equals negative 8. That's the right answer. Okay? All right. So that's it for this assignment. I think we'll do one more of these assignments on linear equations, and then we'll move on to the next topic. And as always, if you have any questions, please let me know. Thanks.